Hello, welcome to November's Erlang Solutions webinar entitled BlockScout Open Source EVM Blockchain Explorer. Today we are joined by Andrew CRAVENHO. He is from POA Network, and we've been collaborating very closely with this company, and today we'll be focusing on blockchain analytics Erlang. So Andrew is the project lead in the BlockScout Explorer project. He will be running us through blockchain architecture, how users consume blockchain data, and how to leverage Elixir in this open source explorer. You can visit blockscout.com to check out this explorer in all of its glory, and also POA.network is the website if you want to see what the gang are up to there. So we'd love to hear from you for today's webinar. You can tweet us at Erlang Solutions. Lastly, you can submit a question using the questions box in this platform, as always, and we'll be having a quick Q&A session at the end. So please keep in mind that this is a live event and that we may experience some technical difficulties, but hopefully not today. So now, without further ado, it is over to Andrew. Take it away, Andrew.
Hey everyone, I'm Andrew CRAVENHO with POA Network. Today I'll be talking about BlockScout, our open source EVM blockchain explorer project. I'd like to start by, actually BlockScout is live at blockscout.com. And if you're interested in contributing, github.com/POA Network/BlockScout. I'd like to provide a little background information on what POA Network is. It helps lead into why we needed to build BlockScout. So POA Network is an Ethereum sidechain. We're an independent network from Ethereum network with a unique state. So we have different accounts, balances, transactions than Ethereum network. We're a second layer scalability solution. Our vision of scalability involves bridging from one network to the other. So in April of 2018, we were one of the first production bridges to be able to transfer coins and tokens from one network to another. Currently, we're able to, so we just released our XDAI bridge, which is a hard spoon of Ethereum, which allows users to send DAI tokens from Ethereum network across to an XDAI chain, where DAI is the native coin on a separate network. So this is our vision of scalability. And this picture of a bridge, I probably should have switched the slide a little earlier. So what is BlockScout? BlockScout is an open source EVM block explorer. Essentially, it's a tool for analyzing blockchains. And this is account balances, tokens, transactions, everything that is on the blockchain, we extract and make it in a visual format so users can see. You're also able to interact with the blockchain by reading and writing smart contracts. The writing aspect is currently work in progress for BlockScout, but we hope to get there in the next couple months. So why did we need to build this full-featured open source block explorer? Many Ethereum users currently use a block explorer called Etherscan. Now, Etherscan is great, but it's centralized. So all its source code is closed source, and users can't actually identify whether what they're seeing is in fact true and valid. So we wanted to create a full-featured block explorer for private networks, side chains, for Ethereum mainnet itself. So users can spin up their own block explorer, deploy it to their own node, and knowing that the address and the balance that they're checking is in fact valid. So this is our idea and vision behind a decentralized solution for the blockchain. And we needed it for our own network. It was very important to us. So the current networks we currently support are Ethereum mainnet, the 3 test nets of Ethereum.
Hi, Andrew. Sorry to interrupt you. You need to share your screen. So if we just go onto the panel there, so you're currently a presenter. Sorry to interrupt everyone. So you just there you go. Yeah. If someone can just type in the questions now, if you see it correctly, then we'll continue. Yes,
I
perfect.
apologize.
Sorry, no,
Sorry
sorry
about
about
that.
that. Please continue.
Well, you guys missed my beginning slides. They were so pretty too. That's okay though. So we currently support 8 networks, including Ethereum mainnet, the 3 test nets of Ethereum, including Kovan, Ropsid, Rinkeby, Ethereum Classic, and again, our 3 POA chains, which is POA Core, which is our mainnet, POA Sokol, and the XDAI chain, which is our newest chain recently. So we currently support 3 clients as well, which is Parity, Geth, and Ganache. Ganache is the default, or actually will soon to be the default client that when you deploy BlockScout. So here are some of the features before we dive into the actual BlockScout architecture. Some of the features of BlockScout. So we have the typical blocks, transactions, receipts, but the real fun begins with, of course, the block reorganizations. So many users don't know that when we're talking to an RPC endpoint or a node, many times our node will think it's on the main chain when in fact it's veered off onto a fork of the chain. So we need to be able to not only revert all of the transactions that we just indexed, but also revert all the balances as well, come back to the main chain, and then catch up to where we should be. And this happens quite often, and I don't think many users actually know that this actually occurs. So this was a big recent addition to BlockScout. We also support tokens, which include ERC20 and ERC721. ERC721 are non-fungible tokens, so every token is unique. Very soon in the future, we'll be providing great metadata for these tokens. So, what the name of this token is and a lot of the other specs that involve around ERC721 tokens. We also have contract verification, and you're able to interact with these contracts directly from BlockScout. We've also included real-time UI, a RESTful API, as well as GraphQL API endpoints. As far as our development stack goes, so we're using Phoenix Framework. We've had the great pleasure to work with Chris McCord, who contributed a few months ago to the project, helped build our indexer. And of course, it's on top of Elixir. And as for the storage layer, we're using a Postgres database. For monitoring, we're using WebServer along with Prometheus and Grafana. And if you guys have any questions on any of this, please feel free to ask. I'll try to stop after each one when I'm going through the actual umbrella applications. So we have 4 umbrella apps within BlockScout. The first is BlockScout Web, which of course is our front end and UI. Then we have our Ethereum JSON RPC client. So this fetches and receives all the data from the blockchain. This was custom built. Next, we have the Explorer, which handles all the business logic and services of BlockScout. And finally, we have the indexer. So this actually organizes all the information, which sends it to the Ethereum JSON RPC client. Next, we'll be talking about each one of the umbrella apps in detail. We're going to first start with the indexer. This is where we first receive the data, and then we'll work down to the BlockScout Web, which is our UI. So we actually have 2 indexers on BlockScout. The first is the Realtime Indexer. This indexer receives or connects via WebSockets and looks for a new head subscription, which basically says, hey, I have a new block and here is the block number. We then take that block number and we go fetch the relevant data for that block. Now, meanwhile, we have a Catchup Indexer, which starts at the tip of the chain. So that's the highest block height and works backwards to the Genesis block. Now, we did this because we wanted to create a good user experience no matter how much data was on the blockchain. So we currently deployed BlockScout about a month ago, but Ethereum mainnet has just tons and tons of data. And if we started at the Genesis block or block 1 and worked our way up, users don't have the ability to see all this data between the Genesis block and the tip of the chain. Yes, we are getting some data from the Realtime Indexer, but a much better user experience is working backwards from the tip of the chain back to Genesis. So this is the reason we decided to go with this architecture for the particular indexer. So here's a little code snippet from our real-time indexer. So we're going to fetch our subscription of our new block number coming in. We're also going to keep the state of the previous numbers that we just fetched. This is because there is a bug in Parity right now where they don't send all of the new blocks coming in. So we need to keep track of which blocks we've seen, which ones we haven't, and we then go fetch if there happens to be any holes from the new block coming in. So then we go fetch and import. And here is the Catchup Indexer. So the Catchup Indexer looks for missing holes in the blockchain in the data we've fetched. So we will look for both going backwards and also if we happen to skip a block from bad requests or whatever the case may be, we will find the missing block ranges, hold that in memory, and the Catchup Indexer will go through and fetch this. And we log this, of course, in either debug mode or info mode, whether production or in development. Now, going further into the actual indexer processes, there's a couple of choices we had to make here. For our real-time indexer, we've tested doing everything synchronously. So there are different levels of the cost of the calls. And there are many calls we have to make when we're fetching a block. We decided to do everything for our real-time indexer synchronously. So we fetch the blocks, and then we need to fetch all the transaction data. And these are all separate calls that have to be made to the blockchain. We then parse all the token transfers. We get all the balances for all the addresses that were involved in the block. And the most expensive call is for the internal transactions. And I'll explain a little bit later what actual internal transactions are. But we chose to do this all synchronously. So a user who's sitting on their address page will receive a transaction coming in, and then they'll see their balance update all at the same time, see their internal transactions come in. It was just a better user experience in trying to do this asynchronously. Now for our Catchup Indexer, we wanted to do all the light calls. So we wanted to do all of them synchronously, and all the heavy lifting we do asynchronously. So it doesn't hold up the Catchup Indexer from getting from the tip of the chain to the Genesis block. And we will fill in all the holes from any of the calls we might have missed along the way using our Catchup Indexer. Next, we're going to talk, is there any questions about how our indexer works or anything like that? Okay, we'll move on to our custom Ethereum JSON RPC client. So what this does is it sends all the requests that the indexer sends to it to the blockchain. So it could be whether it's looking for blocks or a particular transaction receipt. The transaction receipt fetches the status of a transaction, how much gas was used in that transaction. So once it receives the data back, it then maps it to our storage layer. So many of the different clients, so right now we're using Geth, Parity, and Ganache, they will actually send us back slightly different information. So we need to map this to exactly what client it is and be able to import it accordingly to Postgres. If we see new information that we don't expect, we will blow up, but that's on purpose. We want to know if there's an information type that's not right, if it's some extra field that's there. We'd like to see that and map it in the future accordingly. And then finally, the final data is sent, of course, to the Explorer app for import. So this is what a typical one of the Ethereum client process would look like. The indexer sends us a block number. We go out and fetch it. Now, included in that block that we receive back is all the transactions that's also in the block. Now, this doesn't include the status of the transaction. So as I mentioned before, we then have to go out and say, hey, what's the status of this? So we go fetch get transaction receipt with the transaction hash included as an RPC call. From this information, we get the gas used, the events of that. We get from the events, we are able to extract the token transfers for that particular transaction. And then we say, hey, have we seen this token before? If not, we have to go out and make a separate call to interact with that smart contract and say, hey, can I have your name? Can I have how many decimals you have? What your total supply is? And all this other essential metadata that's important to run a block explorer and that the user would like to see. We then have some of these client-specific calls. So once we do this, we need to, and these are the real expensive calls. And the reason for this is because we actually have to run the transaction back through the virtual machine. So when we interact with a contract, there are several underlying transactions that can happen. And these could be interacting with other contracts. These could be making other calls, other value transfers. There are essentially numerous other processes that can happen in the background from the parent transaction. So in order to keep the state of all the addresses that are involved in one parent transaction, we actually have to go and fetch all these internal transactions. And this is the most expensive call that we make. So this is the reason why we run this asynchronously for our Catchup Indexer. Once we receive all this information that we just talked about, we then go fetch a balance for all the addresses in that particular block. This is stored in a separate table, and we do keep the history by block number of every single address on the chain. We actually have an open issue right now. Well, actually, it's a pull request out right now for showing a graph by block number of every address out there. So if you'd like to see your histories, that will be available very soon on BlockScout. All right, so next we're going to talk about the Explorer umbrella app. This handles, again, as I said before, all the business logic and services for BlockScout. This handles all the calls to and from Postgres. This also handles all our outgoing API calls. So we do need to fetch the prices for all the tokens and the coin on that particular chain. And this is handled, that's actually stored in an ETS table. We also store, so we've had a difficult time actually with our count from Postgres, our count queries. It was actually the longest processing time that we've seen, and we needed to do something about it. So we decided to use the Erlang term storage tables in order to hold this information in memory and then be able to call it in a very quick fashion. Some of these count queries from Postgres would take minutes, and that's just too long. The reason for that is because some addresses, if we want to know how many token transfers for this particular address, we're talking about millions of token transfers. And for Postgres to go into a table with hundreds of millions or even a billion records, it takes way too long. So we run this asynchronously, hold it in a ETS table, and then call it whenever we need the information. Next, we have the BlockScout Web Umbrella app. So this is our front-end UI. Our front end is all real-time. So when we receive a new block in, the user doesn't have to refresh the page. We thought this would be a great user experience, especially differentiating ourselves from another full-feature explorer called Etherscan. So these are just the highlights of the front end. We also have our GraphQL, which is fairly new. We're working on building out a full subset of endpoints to show in that. Currently, we have 4 up right now, but we have a dedicated developer working on that. We also have a RESTful API and, of course, contract verification and interaction. All right, so here is a look at our front end, and we'll actually take a live look here. So what we will look at here is this is our POA core chain. And as we see here, we've got the new blocks coming in. Down here, if there are any transactions, we will see them pop in as well. And let me move this. So we can, up here, we're actually able to see other chains. We could come over here and look at the XDAI chain, which is a little different. As you can see here, we have a verified smart contract, so it names the actual address along with 8 characters of the beginning of that address. Next, we'll talk a little bit about the smart contracts, and we'll take a look at one that's on our chain. So when you're looking at an address, you have, of course, the address hash, and if it's verified, we can actually get the name of the contract and show it right here. So in this particular contract, it's actually a token contract. So if we click on this, we will actually go to the token page. So tokens are built on top of the core platform or the core chain and are able to be transferred as we see here. Now we can also look at the source code of this particular contract, and this is why a full-featured block explorer is so important. In order to trust a smart contract and interact with it, you should be able to see exactly what's happening inside that smart contract. So this is what verifying. So basically what we do when we're verifying a smart contract is we compare the source code, we compile it and compare it to the bytecode that we've extracted from the blockchain. We see if it matches up, and if it does, then it becomes verified. And of course, down here, we have the ABI of the contract. Now what we can do is we can actually go look at, from the ABI, we're actually able to see, and this is a transaction details page. So from here, this is one particular transaction that some user sent to this contract, and we can actually decode exactly what happened in this contract. So this particular contract is a game that's run on the POA core chain, and we can see here a user refined cocaine. Okay, well. Not cocaine. It's part of the game. You can see the narco ID is the name of the function used, and it took in an integer, and it was number 457. So this is something that was just recently added. We will be doing this in the future to our logs. So this will all be decoded as well from that contract ABI data. Now I'm going to talk a little bit about where we're going in the future for BlockScout. So most importantly right now is our user experience improvements. As I described before, Ethereum mainnet has just tons and tons of data. And I can actually show this off. I'll actually show BlockScout here. So we'll go take a look at Ethereum mainnet. And we're indexing this right now. So we currently have 203 million transactions here. So if we go look at one of these addresses, a big improvement we've made most recently is improving the query performance for the address page. And I believe I have an example up here of yes, so this particular address has 4 million transactions for it. So when we if we refresh this page, you can actually see how we're loading this asynchronously, this transaction part, and that's to provide a better user experience for the end user. And showing the overview section, and as soon as these transactions are loaded in, we show them. And this is pretty fast for having over 4 million transactions on this page. So this is a big improvement we're still working on, and we want to do it for all the transaction lists throughout BlockScout. infinite scroll. So we've actually, we have that completed for most of the pages now. We are about 80% done there. Users will never have to click any pagination links anymore. And then, of course, faster indexing times. We need to get faster on indexing Ethereum mainnet. We're at 26% now. We're working on this on a day-to-day, a daily basis. All right, and then as far as our indexers, a big enhancement that users want to see is actually being able to define a set of blocks. So this could be if they are hooking up to either their own chain or let's say Ethereum mainnet, and they want to see blocks between 400,000 and 500,000 just to extract some type of data. We should be able to provide that utility through our configuration files to just be able to fetch those particular blocks. And actually, our Geth internal transactions, which again, Geth is a different client than Parity. We just finished their internal transactions and it was merged yesterday. So that was a big project that one of our best developers has been working on for a couple weeks. And of course, as I mentioned before, we're working on faster indexing time, which to do that, we feel like we need more nodes and be able to call a cluster of nodes so we can index more concurrently. We've also been asked, so part of the problem we're seeing is if a user deploys BlockScout, there's different configuration settings all over each one of the applications. We've actually already created the administration panel, but we'd like to include all these configuration options right inside the administration panel. So this is something that we'll see in the next couple months, is being able to customize your CSS colors, your logo, any of the social links. And actually, a couple of the things I haven't mentioned, some enhancements that we have are, so you're actually able to, within a configuration file, I believe it's in Indexer application, config folder, config, you can tell the application not to exceed a certain memory amount. We store all the Catchup Indexer processes and many other things in memory. So as the Catchup Indexer works backwards, it consumes a great amount of memory because it says, hey, I have 1 million coins to go fetch the balance for, and 2 million internal transactions. So all this information is held in memory along with the hash and the block number. So we can tell these processes to shrink. And basically it's stored in the database with a null index time, which when on the restart, it knows to go back and fetch all these missing internal transactions or coin balances, whichever they might be. So we also have another feature on BlockScout, which is it's a backoff setting for the indexer. So the indexer will fetch and fetch and fetch, but it's not talking directly to the node. So we don't know if the node is timing out. So we could be DDoSing the node. And what we do now is we look for timeouts, we look for bad gateway errors, and we tell the indexer to pause for a configurable amount of time. Yeah. And then, of course, you'll be able to enter your RPC endpoints according to which chain you're choosing to index. Another feature we want to add is data export. For a typical user, they don't know how to use a RESTful API or GraphQL, so they should be able to download their transactions and token transfers in an easy manner. So we're going to provide a button to easily download this type of information to CSV, just so they have it in their local machine. So a couple other roadmap items that we're looking at. We want to continue on our GraphQL. We've had some great excitement around that from our community members, which we're excited about. Another excitement for our community is ERC 721 data attribute support. So this is, names of the tokens and different attribute features like showing the image in the Explorer of this particular token. There's some famous games out there like CryptoKitties. So we're looking to show this type of information for the user right inside BlockScout. As I mentioned before, we actually just decoded the transaction input by the contract API for ABI for the on the transaction details page. This was actually just merged last week, so we're happy to have that done. And next, we're decoding the logs by the contract ABI. So being able to see what function was actually called and what arguments were provided is a great visual use for the end user. But that basically sums it up for me. Is there any questions I can answer for anyone?
Yeah, hi Andrew. Yeah, we've got a couple of questions through. Thank you so much for the time that you've spent on this. Really great presentation. So some of the questions we've got, what is the difference between POA network, other networks, and other blockchains out there?
Sure. So POA Network, as I mentioned at the beginning, is it's an Ethereum sidechain. So we have a unique state. So we compatible addresses, but they have different balances, accounts, transactions. And the idea here is Ethereum currently has 13-second block times. POA Network has a set of 5-second block times. So it's faster and cheaper. I think it's 1,000 times cheaper to run a transaction on POA Network than it is to run Ethereum. So the idea here is that you can bridge whether over to POA Network, run all your core infrastructure and your transactions, and then bridge back to Ethereum network if you want to receive liquidity. And that's our vision of scalability. Now, to other blockchains, it all comes down to consensus mechanism. POA Network utilizes proof of authority consensus, where Ethereum network is proof of work right now, in the future proof of stake.
Okay, brilliant. One question here, can this be used with the Hedera hash graph DLT?
I personally haven't tested it, so this is compatible to all EVM chains. I will have to take a look. If you'd like to post an issue right in GitHub, I'll be happy to help you and to deploy it to that particular infrastructure and see if we can get it to work.
Yeah, absolutely. If the attendee there, if you would like to give me your email as well, I can definitely drop you a line and we can get some more info for that for you. So the last question we have here is, what is the future roadmap of BlockScout?
Sure. So I kind of went over a lot of the items here. Some of the bigger stuff I didn't. So we will be integrating IPC into BlockScout very soon. So this means that you can have the node which gets spun up as the BlockScout is deployed. This will allow for faster indexing times. It's something that will happen very soon. Probably within, I say very soon, but probably in the next couple of months as we finish some of these critical items. So that's something exciting for the community. Okay,
yeah, I look forward to that. Okay, so I think that's it for today. So we're taking a festive break next month already, but we'll be back in January with sort of more content, more webinars and things like that. But once again, I'd like to thank Andrew and POA Networks today. If you do have any questions, do holler on social media or send us a message, and we'll whack them over to Andrew as well. But thank you, Andrew.
Thank you very much. Appreciate it.
Okay, bye-bye.